The objective of this recording is to go through a talk that was given to PyData on the 29th of May 2025. The title of the talk was Trading Games as Data Engines, and I just want to let you know that that email there can be used to request an invite to test the game. So annotations, before getting into the talk, I just want to give an example of producing annotations from the game data. It's probably the simplest example you can use, and it's not necessarily a recommendation, but it is an example that will explain the type of data and the uses of that data produced by the game. So there's a thing called a user game series in the game, and under the current configuration there's 50 screens per game, and there's 100 games per user game series, so that makes 5,000 screens or rows of data. They each have 200 columns because each of the choices in the game or each of the screens in the game have time series of 200 length. So what happens is that a user goes through those, and they, on a particular type of game, they sort of says, do I think the chart's going to go up? Do I think it's going to go down? So you end up with the index of the data, you end up with the time series data, and then you end up with the gameplay data, whether it's up or down. Say a user wants to annotate an unseen time series of length 200. They calculate the similarity between the unseen time series and each of the 5,000 game time series. So correlations, just literally do 5,000 of these, and then you rank them and you get, say, the top four. Right? So the top four, assume they were all up, then you could assign a very bullish annotation to that unseen time series. Alternatively, to roll down, you would assign a very negative or bearish annotation to that time series, and it was somewhere in between, like you're getting kind of neutral. So here's the Python code to actually do that. You see that all you're doing is it's in a data frame, and you're just working on correlations, and you just sort of sort these correlations, and that's all there is to it, and take the top n. So a couple of things I want to say about the annotations. They're very unique, and why they're very unique is that no two users would make the same game choice. So I think that brings the potential, a lot of potential in the game. The next thing is that the annotations can be used either directly, because you're creating bullish and bearish percentages to actually select securities, or they can be used in a training model for a trading system. And the final thing I want to say about it is that it's very transparent what's going on, in that you can actually bring it back to individual rows in this example to sort of figure out why are you getting a very bearish or getting a very bullish read on a particular unseen time series. So let's talk about the app. So the app is called Choose Chart, and it's an iOS and Android trading game. And literally what it does, very simply, you're given a historical time series chart, and you're asked something about it, like, do you think it's going to rise, do you think it's going to fall? There's other types of games, but that's all that's happening. The initial version was released in 2024 on App Store and Play Store. There's a test version that you can request an invite to test, and I'll explain all you have to do later on in the presentation. So what happens here with the app is that we have a very large, here's the architecture diagram. We have a very large thing here, which is the iOS and Android app. There's two other apps. There's something called a game series creator in Python, and then there's a thing called query creator in Python. So let's get to the game series creator. It takes your rates file and then 3 manual configurations, which is rates, term, and game type configurations. The production, what you produce from this is model instances that are outputted in JSON format. And these model instances have two uses. They can be used to populate the games within the iOS and Android app. And some of these apps, some of these game series are loaded the first time you load the app. Others are loaded on request, so they're kind of lazy loading within the app. So that's just to keep the app performant and stuff like that. Then, so the other use of these JSON files is in the query creator. So what happens, think of a query creator as a very easy means to get information out of the app about, say, a user's trading style, what their current view on a particular stock or foreign exchange foreign exchange rate is. So it's just a means to actually use the data that's created within the app. The second thing I want to show here is the other way you get to use the data is that you can actually export the raw data within the app. So you see that here. So here's some screens from the app. The first thing I'll show you here is the screen on the left, which is kind of like the home screen. So you can select between different types of game series, and then within game series there's different types of game types. So the example here is a crypto game series, and then there's a particular type of game where you select between two charts. Then there's some gauges to tell you where you are in a particular game series, user game series. Then there's other gamification items here. You have your chart to see how you're doing through time, like are you improving or disimproving as you play the game. And the second screen there just shows a screen of the game. So the number of observations in that screen is 200. And then at the end of the game, what happens is that you can look at your individual choices. So in this example here is that here was your 200 period, and then you had to look at the screen like over here, and then after there's a 100 period, which you sort of say, well, what's going to happen over the next 100 periods? So in this instance, somebody selected the red chart, but you see that the red chart ended up below the blue chart, so they lost. So it's just after the game, you're kind of, you're told, where you were right and where you were wrong. So I'm going to refer back to this chart in a while. A couple of things about why the chart was created the way it was created. So the next thing is that why do you choose charts? So the first thing is why is the chart useful? And it's because of charting and bias-free chart choices or behavioral sort of learnings from behavioral finance. So let's talk about charting or technical analysis. And basically, technical analysis says you can actually, it's possible to learn how to, there's repeatable patterns in charts that can be used to estimate what's going to happen, by simply looking at a chart. And one of the things, so, in order to sort of hopefully convince you that there is something in this, what I would say about charting and technical analysis, it's established. Like it's been going for over 100 years. One of the things I would mention is that Dow Jones, the Dow, he was actually somebody who worked on, publishing articles about technical analysis over 100 years ago. There's some very established, charting associations throughout the world with very large memberships in all, virtually all banks and investment managers would have someone, or if not a department, who works in technical analysis. The second thing I would sort of say, it's very popular today because of the type of markets that people are trading. It's become very popular. Like you've got TradingView, which is the most popular website for charting. It's got over 50 million users. And also when you're trading very short-term markets, stuff like that, like say minute to minute, hour to hour, day to day, is that it's probably your only choice, if you want to sort of figure out, get see what's going on. And one of the things I would sort of say, the next time you see on the television or online, trading room, you'll see an awful lot of screens actually have got a chart, something like this, and here's a chart from TradingView, and you'll see, so people trading, professional traders, they use it, so that kind of tells you something also. So a couple of the things from charting is that they sort of say things go on trends. Well, there's a trend, there's another trend, not so much of a trend here. Also, extremes in one direction or another tend to take on importance after the fact. So here's something from 2022 that very recently became quite significant in this recent sell-off, and this is in the S&P 500. So that's an example of a chart. So the next thing I want to so that's kind of making the argument for charting. But the second thing you get from the app is this thing called bias-free choices. So I want to refer you back to here. There's no tickers, there's no dates, and there's no prices on this chart. And these are all deliberate choices. And why they're deliberate choices is that I believe that these biases, and also there's a lot of evidence from behavioral sciences that these biases affect your objectivity when you're actually making investment choices. So you should avoid them if you can. And a lot of people who are trained to be traders, they're trained to, dampen these biases. So within the game, because it's a controlled environment, we might as well get rid of these biases. So that's a very deliberate choice, and I think this improves the choices because it makes all the choices equal. The second thing is that behavioral finance is that the negative impact that excessive optimism or pessimism can cause in your choices. And what I mean by that is that you become it just affects your decision making process. So one of the things that the game does is that it doesn't show you results until after the game. So you play 50 screens, but you don't figure out, whether you were right or wrong on individual screens until after the game, because I want to avoid, people becoming overly pessimistic or optimistic if they have a run of, good or bad choices. So that's another thing that makes the environment that a user is actually making these decisions as equal. So every single chart is equal. And the final thing I'll say about this is that this is quite unique in that, a trader would never go in the morning and not know, what they're trading, or, well, they know that, so this is a very kind of, it's a unique environment that creates unique choices. And, potentially this uniqueness is something that's valuable to a user. And you play the game. Obviously, I believe it is, very valuable. That's why I created the app. But I would sort of say consider it, and I think you'll find that there is something in this. So I'm going to get on to the design principles that was used to build the app. So it's private, it's open, it's configurable, it's efficient, and it's modular. So let's go through these one by one. So the first thing is that, as I've been trying to emphasize, I believe the data created by this app is incredibly valuable to a user. That's why it's kept private. There's no internet connection, and also it's just I think you get a better choice made by the user if the user knows it's private, because there's no competition brought in and stuff like that. So it's a user can be freer in making choices. So I think all this adds to it. And just one thing is that there's also a business advantage for myself because there's less regulations involved. The second thing about the app is that it's open, and what I mean by open is that you can export your gameplay data, and also it's queryable. So exporting is just quite simply you're exporting a data file that sort of says here's all the choices you made in this game. And the second thing is that it's queryable, and remember I sort of said in the architectural diagram you can easily create query files within Python. The next thing is it's configurable, and this is quite important in that you want to be able to add games quite easily without having to reprogram the app. So it just makes the app quite easy to extend. And also just configure means that you can add different types of data sets. So let's look at an example of a configuration. And I'll go through some of these in detail later on. But so what happens, you have data sets, then you have collections of rates within that data set, which is what I have, it's called rates map key. And then is the minimum and maximum time index. And what I mean by that is certain times you might want to restrict what time period you're playing a game for. To give you an example, is that like you might sort of say, I only want to play interest rate games for possibly the 70s, so because there's a lot of inflation in the 70s and there's a lot of volatility in interest rates, so you might sort of say I want to restrict it there. The next thing is the game periods, and at the moment it's 200. Like you need a critical amount of observations for somebody to be able to see a pattern in the thing. So I kind of go with 200 at the moment, but that's configurable also. The number of charts per game at the moment, as I said, it's 50 charts per game. You don't want it too short, you don't want it too long, but it's just kind of like a nice round number. And why I say it is that, it takes a couple of minutes to play the game, and you don't want the player to be getting too tired during the game. And then the games per user game series. A user game series is a kind of like a collection of games that you can do analysis on, and you need a critical number in order for to avoid spurious results. So it's 100 games per game series, and it's 50 screens per game. So you get 5,000 rows, as I showed in the prior example. And then there's different types of game you can play in the game within the system, and you can kind of group these together within a game series. And I'll give an example of why you might want to do this later on. And then the game type, which I'll also talk about, and then the selection source. And that's just basically what charts, like you might have a data set that's going back years. So how do you select charts within that? And I'll explain that a little later on. So the first thing is your data sets. The data sets can be either public or private, and why you might want a private data set or a private game series is that if you're running using the app to run a competition, you don't want to let people know specifically where the charts come from and what dates are on the charts, because then they can game the results, and you're not running the competition then. All you're doing is running the competition to see who can, read a data set, so that's, so but the system allows those to be distinguished. And the other thing about data sets is that you don't have to use all the data set within a game. You can actually take a subset of it. And to give you an example, if you had a data set of foreign exchange rates, you might decide to take a subset of the major foreign exchange rates because you think that they behave differently than other types of foreign exchange, like some minor currencies, to give an example. So one of the things to be mindful of when you are actually taking a group of rates together in a game, that they should have the same character. And what I mean by that is that certain time series are mean reverting. So things like interest rates, I suppose, are mean reverting. Commodities are mean reverting, whereas things like foreign exchange and equities aren't necessarily mean reverting. So you need to be mindful of that. And also you need to be aware of the fact that, say if you had very short frequency things like commodities, is that they're not mean reverting, because say you've got hourly rates, but if you had say daily, weekly commodity rates, they would be mean reverting. So there's plenty of things you can look up on the internet about that. So that's your data set. So here's an example of a data set within the system. Foreign exchange, this is kind of like major foreign exchange rates. So I just want to let you know is that usually it's a one-to-one mapping between a rate and what I would call a ticker. But sometimes tickers can be used to create rates, and the example at the end of this screen is euro, yen and euro sterling. So euro yen is a calculation between $2 rates and also euro sterling. So this means that you don't have to store as much data within the data set. So, and also you can make these things as complicated as you want. So you can have multiplication, division, addition and subtraction within these calculations. So let's talk about game types. At the moment, there's two types of game types. There's a one chart game types and there's two chart game types. So one chart game types, you might sort of say you're given one chart and sort of things going to rise or fall. But you can go beyond that and you can sort of say, what do you think you're going to see first, the rise or the fall, within a chart? And also you might sort of say, does the high percentage exceed the low percentage? So say the largest increase during the game period was 10% and the biggest fall was 5%, then it would be larger increases. The next thing is charts of two games. So you ask which chart to rise the most at the end of the game period. You might ask which chart to rise the most over the game period. So that's slightly different in that, say one chart had a very significant increase towards the start of the game period, but fell subsequently and ended up below the other chart, is that it still would have, if that high it met, was higher than the other chart it met, it would have won the game, I suppose. Then another example, which chart to fall the most over the game period. So it's just different ways that the games can be configured, and we'll see why this is important slightly later on. The next thing I want to talk about is selection source, and that's you got your data set and you need to select your 5,000 screens per user game series. So how do you come up with these screens? It defaults to random, but you can actually create custom Python functions, and sometimes you might only want to select games when certain technical conditions exist, or to overlap charts to see impact of chart increments. So to give you an example of when certain technical conditions exist, some people are very interested to see what happens, say, when a 50-day moving average of a time series crosses a 200-day moving average of a time series. So you could easily create a Python function to only create screens when that occurs. So that's an example of when certain technical conditions exist. The second thing is that to overlap charts, and what I mean by that is that say you have a chart of 200 periods. So say you move it through time by 10 periods. So what happens then is that you're adding 10 and you're taking away 10 observations from the original time series. So you can actually compare the user's choices between those two types of charts. So you can sort of say, well, what's the impact of removing time series and adding time series to the original chart. So another example would be having chain selections. So here's quite a spurious example, but if you look at the currencies here, you'll see that it's like a progression. So you have a game, say US dollar sterling against sterling euro, and then you have euro Japanese yen against US dollar Japanese yen. So you see everything is linked by at least one currency pair to the prior example. So it's just a way to you have to think about this, but this is a way to sort of verify and to sort of see how strong is someone's opinion on something, because everything should be consistent with each other. So I just let you think about that. But the second thing is that having inverted selection. So you can ask a person, on a particular day, US dollar, Japanese yen, or Japanese yen, US dollar. So they should give opposite choices. So this is another way of verifying, how strong a conviction someone has about a particular rate. So there's plenty of things, you can do to kind of add sophistication to the selection of the charts that are in the game. The next thing is that it's efficient. There's an awful lot of things, and most of them are quite technical to describe, the data. But what I want to sort of emphasize is that that you can add about 10,000 screens, quite easily per megabyte, and you can probably get even above that. So it's very, very extendable, and it makes it possible to store an awful lot of data on your phone and in very small files that, once you export, you can keep them on, wherever you want. So one of the things that's done to achieve this is that individual charts are inflated from a dataset file. And also, so here's a dataset file, and what you have is that you just literally you have one very large file there with all the rates over time, and this could be thousands of rows long, and each of the rows has quite a lot of observations, because especially if it's quite a large data set. And then just each of the ticker dates just has what is your ticker date and what is the tickers for that particular date. And the individual items you store for a chart is just these set of integers. I'm not going to go through what all these refer to. And then there's just one short list here that usually is up to about possibly 4 long, but you can see that that's very efficient means to store data. And it means that it's very, when you add data, once you have the data set file, you can easily add game series without adding very much to the app. The next thing I want to sort of say is that the game is very modular in that there's simple modular questions that are asked of the user, and these games can be produced to produce sophisticated answers. So to give you an example of what I'm talking about here is that assume I want to ask something quite sophisticated about a user. I want to ask, okay, I give you 2 charts, and I want to sort of say, Do you think which of the two charts you're going to, outperform the other? But in what environment? Is it an environment where both of the charts rise? Is it an environment where both charts fall, or is there a mixture? So you see that you have to be very specific in what you're asking. And so if I was doing that, I'd have to give the user the following 6 choices. And I think that this is a problem because you're you're not thinking about the chart, you're thinking about the question, and it just makes it. I think it makes it infeasible. So an alternative is to use the same data on a number of different games and combine some simple questions. So here's the games. You've got dollar yen against, say, euro sterling, and then you got dollar yen against whether it's going to rise or fall, and then euro sterling whether it's going to rise or fall. And literally each of the individual questions are very simple, like which of things is going to outperform, and the second and third one whether they're going to rise or fall. And if you think about this, you get something very similar to what was in the original, 6 questions. So I'm not going to say anything else about this, but except to say that there's an awful lot of different game types, rather than just, whether it's going to rise or fall, or whether one chart is going to outperform another. And I explained those in a prior screen when I gave examples of one chart games and 2 chart games. So let's talk about the technology. The iOS and Android app is written in Dart and Flutter, and one of the advantages is that you also get Windows, Mac, and Linux. And the advantage of these is that you get a local database provided, and there's minimal native configurations required for Dart or Flutter compared to React Native, because the app was previously written in React Native. So the data model is SQLite, and there's over 30 data classes, but there's only 17 database tables. And what you have certain fields that are JSON fields. So within the database, they're stored as text fields. The other thing is that you need to be able to communicate from within the Android app, and there's a thing called sharing intents, which allows easy communication with other apps, but also it allows you to open up files that are created, like say query files or something like that, and it literally you click it and it says open as. So it's a very non-technical way that additional data can be introduced into the app to query your gameplay data. So just what I'm saying there is it can be opened from files with an email or WhatsApp. So if you remember previously in the architectural diagram, I gave the game series creator and the query creator as examples of Python projects, but also there's marketing material produced for Python. So here's the Python game series creator. The inputs, as I said in the architectural diagram, are JSON rates, term rate, and game type configurations. And outputs are model instances that can be populated directly in Dart. And I just want to show here is that the code that's required for Dart and Python is very similar. You're basically reading in JSON lists, and they're just static files in both Python and Dart that just read it from JSON. So the thing about it, if you remember, the game series creator was used as the outputs from the game series creator were used as inputs for the Android app and iOS app, but also for the query creators. That's why I'm showing some Python production code here. So one of the things that I just wanted to explain, because this is a Python meetup, is that managing models in Dart and Python is the issue with consistency. And just to explain that there's the dependencies I use in Dart and there's the dependencies I use in Python. The only non-standard library in Python was a data class -JSON package. And what I would say about managing the consistency, it was remarkably easy. And what happens within both systems is that deep objects that are in the data model, it's not a problem going to and from JSON, because you just recursively call functions, the JSON functions, and the only exception was the enum and list enum classes. And what you have there is you have to create in Python from enum and t to enum functions within the enum class, and that's to make it consistent with the default that occurs in Dart. And the problem is that you didn't want the default within Python when you're serializing and deserializing would be for, say, in this example, learn calc name dot macd as a string, whereas what you wanted was the Dart default, which was only macd. So you needed to define these to and from encoders and decoders. And there's just a slight bit of additional code you need if you have a list of enums, and here's the code. So the next thing I used Python for was marketing material. And there's a very established library called Manum, which I would recommend, but the example I'm going to give here is matplotlib animated GIFs. So the animated GIFs use data from the app, which makes it very easy, and also it's those instance files that are produced by the game series creator. And the update function I'm going to use, the example I'm going to give here is an update function for a thing called func animation within Python's matplotlib. And what you need to do is you need to create different stages in the animated GIF. So the first stage is sort of say, well, here's a couple of charts that you're going to see. Next thing is to show the charts. Then you have a countdown, and then you need to animate what's going to happen in the game period. And finally, you're just going to show some marketing material. So you want to do is you want to sort of give something that's kind of similar to the app, but in an animated GIF. It doesn't have to be precisely there, but it's just to sort of get people interested in maybe requesting information about the app. And there's just some additional things. So the critical thing here is that there's your func animation. You do an update, and there's an initial function, and then number of frames and stuff like that. So then what happens is that you get something like this. So there's your first thing, here's your second thing, your chart. It gives you a countdown. Then you sort of say what happens. You're going to win or lose. It also identifies what the charts are, the time periods, and then finally what you're going to see is you're going to see, yes, here's how you get information about this app. So that's what you do. So the final thing I want to talk about is queries. So queries is means that you can actually find out information about what's happened in a game. And why that's important is that it allows you to keep the data private within the app, but get information about what's happened, what your gameplay data says. So what I would say it's very similar to, it's similar to getting aggregate queries out of SQL without, you don't actually get information about the individual rows within SQL when you're getting aggregate queries. So to give you an example is that, another example why queries are very important is that, remember the example at the start of the presentation, we were sort of saying is the raw annotations would be the individual game choices, but if you use that, you lose the privacy of the data. So it's better to sort of use queries to produce the annotations. So it's incredibly simple. What happens is that all you have to do is you have to populate this model here, and I'm going to give you an example of a row you get, and the first thing you do is gameplay data query ID, just something to connect rows together. Because if you have more than one row about this individual stock, you might sort of say, just give it some unique ID. The user game series ID is important because you need to sort of say, what game series do I need to link up to? The next thing is just give it a list name. That's just something to identify it. So this thing is about looking for an information. I've got an unseen time series on stock 1. The next thing is sort of say, what rows within that user game series are the closest to the actual game I'm looking at? Sorry, the unseen data series. So I just assume there's 4 there. And finally, what you do is you sort of say is that if these are the game choices, so you assign 0.25 if a particular user made the first game choice and minus 0.2 if they made the second game choice. So to refer back to the initial example, 0.25, the first index would be the up choice and the second index would be the down choice. And what would happen then is that if there was 4 ups, you would get a measurement of 1. If there was 4 downs, you would get a measurement of -1. And anything else, you would get something in between. So you can see that this is a very easy way to actually get information. So what would happen is that this file, this record, which is, or this row of information, which is would be a very small piece of information, is sent into the the app, and the app would come back and sort of say, give you some number between 1 and -1 and assign it to stock 1. So you can see that it would be possible to send in thousands upon thousands of individual stocks or cryptocurrencies or currency or foreign exchange rates and get back information very quickly. So that's basically everything I wanted to say about the app. Thanks.